Riverbed Granite introduces a new architectural approach that does for edge servers outside of the data center what virtual desktop infrastructure or VDI did for desktops, and that is to allow IT to consolidate and manage all edge servers in the data center. This new approach, edge virtual server infrastructure, is delivered by Riverbed Granite. Granite solves the problem at the block level and does what was previously thought impossible. It allows storage to be decoupled from its server over thousands of miles of distance and actually work as if the storage were local to the server. Granite consists of a number of innovative technologies. Granite's file system-aware block-based acceleration understands the range of random blocks that are required when opening a file. Granite has an authoritative read cache, which ensures that active data is present and delivered at land speed. In fact, you can pin the storage LUN to the branch and ensure that an entire working set of data is always present, yet is safely secure, including any changes made to the data in the data center. And for write performance, Granite accelerates block writes, once again providing fast local write access with write back to the data center. And because the local Granite device is authoritative, it alone owns the data that is streamed back to the data center, and consistency issues are eliminated. To demonstrate Granite's block-based acceleration capabilities, I have a configuration with a file server in a branch office. I have virtualized this file server and placed it in the Steelhead EX appliance platform. I have mounted a storage device on this server that I want to use as my data drive. However, this local drive is actually located in a data center which is more than 3,000 miles away over a WAN connection that is 10 megabits per second and 80 milliseconds of round-trip time latency. To kick off the demo, let's first take a look at a configuration without Granite deployed. I am logged into the branch office server, and the window on my left is my local C drive contents, and the window on the right has the contents of the E drive that is mounted over this 80 millisecond round-trip time connection. Now on my local drive, I've got this large folder of files that I'm going to go ahead and take and drag and copy over this high latency connection to the remotely mounted storage device. The first thing that you'll notice is that the progress bar indicator is not even moving. So this is a painfully slow operation. This is a file folder that's about 200 megabytes in size, totaling about 17,000 files. At the same time, I've got this folder on the remotely mounted storage device labeled confidential that I want to delete. Now I'm going to go ahead and delete this folder, and this is a demonstration of not only file copy operations, but just working with remote folders can be a pain when you're working on a remotely mounted storage device. So this is a combination of a number of factors, but mainly the inefficiencies of block storage and the thousands of transactions that are taking place, each transaction incurring the penalty of the round trip time. So this is going to take quite some time. I'm going to go ahead and delete this operation and or actually minimize this and go to a configuration with Granite enabled. So in the same configuration but with Granite enabled, we're going to go ahead and perform that same copy operation. Drag that folder of files over. Again, 17,000 files totaling 200 megabytes. And the first thing that you'll notice is that the progress bar indicator is humming right along. So this is extremely fast. Again, we're going over 80 milliseconds of round-trip time latency, and we're performing a large folder copy operation. At the same time, let's go ahead and delete that confidential folder like we attempted to do without Granite before, and let's see if we can improve the scenario with Granite. So here I'm starting the operation. This typically takes about 7 to 8 seconds on a local area network. And with Granite, it looks like the operation is going to take about the same, land speed performance. Let's go ahead and go back to the configuration without Granite, and it looks like these operations are going to take quite some time. Granite makes the impossible possible. With Granite's file system-aware block-based acceleration, A complete operating system can be booted real-time over a slow wide area network connection. In my demo setup, I have an ESX server in the branch office that is configured to launch a Windows 2008 server virtual machine image located on my SAN in the data center. The WAN connection is 10 megabits per second and 80 milliseconds of round-trip time latency. To demonstrate booting a Windows server over this high-latency WAN, I am logged into my ESX server with my vSphere client. The Windows on the left is not configured to use Granite, and the Windows on the right is configured with Granite. I will start the boot sequence for both configurations. It looks like we're already getting some activity with the configuration with Granite, where the Windows configuration on the left without Granite continues to be black. Now, booting over a wide area network without optimization can not only be poor performing, in many cases, the boot will actually fail altogether. Now, it looks like we're already getting some progress indicator on the right with Granite, and it looks like we are into Windows. What took basically less than 45 seconds to boot over a wide area network connection, once again, that is 10 megabits per second with 80 milliseconds of round-trip time latency. Now, the boot sequence without Granite in this configuration can take anywhere from 20 to 30 minutes.